So today we'll learn about states of matter. What is matter? What is state? So first talk about matter. Is everything you see around are called matter or not? Think about the chair or the sound you're hearing right now or the light being reflected in your eyes. Are everything matter? So let's know about that. Matter is anything that has mass and occupies space. Mass is the amount of substance present in an object, and volume is the amount of space occupied by an object. So think about your own body. Your body has a specific amount of mass because it has a specific amount of substance, and it has also volume because it has length, height, width, right? And here the water, air, ice, oxygen, wood, iron, all of these things are considered as matter because they have mass and they occupy space. But what if light, heat and sound, electricity? Why these are not considered as matter? Because they are a form of energy, nothing else. They don't have mass, they don't have any volume. Here the balloon, the ice cube, the glass of water and the apple, all of these things have the specific characteristics of a matter. But these waves coming out of this source, these waves, what is this? This waves is a form of energy. This is a form of energy. So this energy is not matter, because it doesn't have any space, doesn't have any mass. So the properties of solid, liquid and gases. There are three states of matter. One is solid, one is liquid, one is gas. So solid has a fixed shape and a fixed volume and has a fixed mass. Of course matter will have mass. Particles are very tightly packed in a regular arrangement with strong attractive forces, and the attractive force is called the intermolecular force. The attractive force is called intermolecular force. And here the ice cube, if you see the microscopic structure of it, electromicroscopic structure, you will see atoms or ions or molecules. The molecules are very closely packed. They don't have any gap you are seeing, or very small gap. That means they have higher intermolecular force. Here is the 3D structure you are seeing. There is the bond, here is the bond, and it is a molecule, it is another molecule, the bond between two molecules. They are very tightly packed. They are solid. And in liquid you will see they will have no fixed shape. If you keep an amount of water in a glass jar, it will take the shape of a glass jar. And if you will take a large container, it will take the shape of a large container, but it has a fixed volume. The volume will be fixed and it has a fixed mass. Particles are close together but can slide past one another. Why? Because they have a gap. They have gaps, and that means their intermolecular forces has become lower than the solids. And when they have the lower intermolecular forces, they have some surface tension. They can slide past one another. After liquid, we will know about gas. Gas have no fixed shape, no fixed volume. It fills the entire container. The gaseous molecules are very far apart from each other, and they don't have any intermolecular forces. Actually they have, but the amount is very less, that it is nearly zero. The intermolecular forces is nearly zero, not actually zero, but is nearly zero. That's why they are called independent molecules. They move randomly, very fast, they have high kinetic energy, and they move freely in all directions. So here are some basic differences between solid, liquid and gases. You can read it through. Then we'll know about the kinetic particle theory. What does it say? We will describe this theory in terms of kinetic energy and intermolecular forces with the help of these two particular terms. So in solid, the molecules are very close to each other. That means their attraction force is very high. That means intermolecular force here is maximum, and the kinetic energy is very low, almost nearly zero, but not zero, nearly zero. If you heat the solid, the solid particles will be a little bit distant from each other. The molecules will be distant, there will be gaps, and thus their intermolecular forces will be reduced, and the kinetic energy will be higher, because when you are heating it, it will absorb energy, and it will, while absorbing energy, it will transform into kinetic energy. So the kinetic energy is getting higher here. And lastly, the gaseous molecules. The gaseous molecules are showing maximum gaps, right? That means their intermolecular force is the lowest. Their intermolecular force is lowest, almost nearly zero, nearly zero, nearly zero. And the kinetic energy will be maximum. Kinetic energy is maximum. They will move randomly. Here the description about kinetic particle theory. The particles, matter is made of tiny particles. They are in constant motion. We saw in solid that they are very close to each other. They are very close to each other. And when we heat a solid particle, the molecules will form gaps between them. Why? Because they gain kinetic energy, and after gaining kinetic energy, the solid turns into liquid, and the liquid, after we heat a liquid, it will turn into gas. And how they turn into gas? Because the kinetic energy will be very high, the molecules will have greater distance than any other state. Thus the three state can be explained with kinetic particle theory. So here the description, you can read through it: kinetic energy, intermolecular forces, and eventually the change of state. So change of states of matters, how do that happen? By melting, by freezing, by boiling, by condensation, or by evaporation. So first we will read melting. Here melting, solid will turn into liquid, and freezing is exactly the opposite of melting. The liquid will turn into solid. Here melting will be happened at melting point. This is an important point to make. At melting point, think about ice. Ice, what is the melting point of ice? The melting point of ice is 0 degrees Celsius. So ice will melt at 0 degrees Celsius. So the specific solid which has a specific melting point, it will melt at that specific temperature. So how do that happen? It gains heat energy. When you heat the solid, it will gain heat energy, the particles will move faster, and the solid will change into liquid. The particles are moving faster and they are forming gaps. The solid are moving liquid. And freezing is just exactly the opposite. They will become freezed at the freezing point. For example, ice. What is the freezing point of ice? Exactly the same, 0 degrees Celsius. The freezing point and the melting point is same. So why the freezing point and melting point same? We'll know about that at heating curve and cooling curve later. So first look at here. In terms of freezing, the molecules will lose energy and they will become tightly packed again, and they will become solid. Here, if you are heating it, it will become liquid. If you are freezing it, it will become solid. Here is the description you are seeing. Now boiling. What is boiling? Boiling means liquid will be converted into gas by heating. Evaporation. Here also the similar thing, liquid turns into gas. But what is the difference? Both of the terms are used for liquid to gas, but what's the difference? The difference is boiling will be occur at the boiling point, but the evaporation will occur below the boiling point. So let's get more into it. First, you are seeing water here. So the water molecules are getting heated up. So after being heated at 100 degrees Celsius, the molecules are being very far apart from them, and they are becoming gases. But in terms of evaporation, the molecules from the surface are being turned into gas, by absorbing heat from the surrounding, So absorbing heat from the surrounding, evaporation will occur, but the boiling will occur when you will heat the whole liquid. That's the basic difference of evaporation and boiling. Here bubbles will be formed, but in evaporation there will be no bubbles. For example, you can say in winter we dry our clothes. The sun is not giving very much of temperature, right? The temperature is low. In low temperature, then how does our clothes become dry? because of evaporation, because from the surface of our clothes the water molecules become vaporized and thus our big clothes become dry. Here is the differences, you can read it through. Condensation, gas will turn into liquid. How the gas will turn into liquid? It is the exactly opposite of boiling. It is the exactly opposite of boiling. When you freeze or when you cool down gaseous molecules in a container or in a box, then it will loses energy and the molecules will be tightly packed, then it will turn into liquid. Not as tightly packed as solid, of course, but they are more close, they are closer, right? They are closer than the gas. Here is gas and it's liquid. So condensation loses heat energy, particles lose kinetic energy, of course kinetic energy, and they will gain some potential energy here, and particles move closer together, gas changes into a liquid, and water droplets form on a cold glass. Now heating curve. What is heating curve? Heating curve shows that the temperature of a substance changes as it is heated. When you heat something, for example, we'll use the example of water here. Below zero, what is the state of water? It is solid, right? It is ice. So when you heat the ice, the curve is getting up, the curve is going upward. But at 0 degrees Celsius, the curve is horizontal. Why it's horizontal? Because it's gaining, it's heating, it's absorbing the heat, of course it's absorbing the heat, but it's changing the state here. Here it's changing state. The heat is used in changing from solid to liquid, changing the state from solid to liquid. Here exactly it was solid, and at this point all of the molecule will become 100% liquid. And here at solid, what is happening actually? We saw at kinetic theory of particles what happened. Here the molecule, here the kinetic energy is being increased and the intermolecular force is being decreased, and after that after it turns into liquid, then the curve will go upward. That means the intermolecular forces is going down gradually and the kinetic energy is going up. That means the molecules are being more apart from each other, and at this point the liquid will gradually turn into gas, and at this point it will be 100% gas. That means the kinetic energy will be higher gradually more than this area, and the intermolecular forces is the lowest here, and that means nearly zero. And at this point, at this specific point, the kinetic energy will be the maximum, and after that the gas will be more ionized. Let's not talk about the ionized form, that is plasma, but we don't have that in our syllabus, so we don't have to learn that. Solid heating, here is the description. From solid heating, we are heating the solid, then it's melting, here it is melting. Then liquid heating, we are heating the liquid up, then boiling, then at this point at 100 degrees Celsius is boiling, and the gas heating. Now we'll learn about the cooling curve. Here we are learning about the cooling curve. And what is cooling curve? It's exactly the opposite of heating curve. Here we will just freeze the whole thing. The gas will lose energy. At this point the gas will gradually turn into liquid, and in between we'll get the mixture of gas and liquid, and from this point the curve is going downward. That means the liquid is giving up more energy, that means losing energy, and here the liquid molecules are being tightly packed, and at this point exactly we will get the solidified form, and after this the solid will be more tightly packed, the molecules will be more tightly packed. That's all about the heating curve and cooling curve. These the heating curve and cooling part are the most important parts here. And now it's a very small